So here we are designing a circular patch antenna which is capable of resonating a multi-model. That is, there is something called as multi-model antenna. That is when you are if you consider like mobile phones, the antennas we have in mobile phones, these are used for multiple functions, right? There is Bluetooth, there is Wi-Fi, or there is other calling functions. So there are many functions for that antenna. So this antenna has to resonate in more than one frequency, at more than one frequency. So we're designing a circular patch antenna in such a way that it can resonate at more than one frequency. Okay, so as usual, whenever you're designing the antenna, the first thing there are three things which we need to know before you are designing an antenna. First one is the resonant frequency, and then what type of substrate you're using, what is the dielectric constant of the substrate, and what is the height of the substrate. Okay, so whenever you are using HFSS software, so there are some four steps with which you build an antenna. So the first step is that you have to physically design the antenna. That is, you have to give the measurements, you have to give the dimensions of ground, of substrate, patch, feed, port, all that things you have to design first. And after designing that, then you have to go for boundaries. You have to give some boundary conditions to specific parts, and then you have to give excitation, and then comes the analysis part where you have to give the frequency sweep, and then you have to validate a model, and you can simulate the model. Okay, so here first let's start with the ground. So you can see this is the ground. So here all the dimension that is used, it is 50.3 and 115.7, and the position everything is given. So this is what the ground is. This is what we use for a ground. And then after ground, you have the substrate. The substrate has to be a solid, because ground we are taking it as a sheet. So when you are considering something as a sheet, the HFSS, you don't have to give any material for it. HFSS, it takes it will give, if you can make it, you can make it conducting, or that you can do it, but you cannot give any material if you are considering a part as a sheet, right? So ground is a sheet, so you cannot specify any material. But when you come to substrate, it can be made as a solid. Okay, so we are taking a solid box and we are making a substrate on top of the ground. Now you can see that, if you just double click and see that the substrate, the material used is FR4 epoxy. There are various materials you can use. So this is actually dielectric materials. There are various dielectric materials you can use. Now what we are using FR4 epoxy, which has a relative permittivity of 4.4. That is, it has a dielectric constant of 4.4. Okay, so this is our um, this is our substrate. And now when you see the dimension of substrate, it will be same as that of the ground, and you can see the height of the substrate is 1.6 millimeter. That is the height of the substrate. Okay, so we have designed the ground, we have also designed the substrate. Now our let's come to the patch. So here we're using two circular patches. So when you're using one patch, then it is called as it's just a patch antenna, right? But when you're using more than one patch, it is known as an array antenna. Okay, so here we're using the simple array antenna, we're using two circular patch, right? So you can see that yeah, this is the, there are two circular patch. So these are the circles. So this is the radius of the circle, 17. It is the radius of the circles. That's the radius of the circle. And you can also see that this is another circle. It has the same radius. So you are actually making two circles. This is one circle. This is another circle, which is patch and patch one. And then you have to make this the small the feed line that is coming. Okay, we have to make that. So we are actually making it as like two separate rectangles, and you're just uniting them. You can see that this is one rectangle. It has the dimension, this is the dimension of the rectangle, and you have four rectangles, and where you're just uniting them. So you have two patches, and you have like two feed lines coming from these patches, which is coming to the port, right? So that is what this is. So you have two patches, and all these feed lines, they are all united. When you just select one, you can see that the whole patch plus the feed line, everything is getting selected, because we are uniting everything, uniting the two circles, all the rectangles, everything we're uniting, so that it will form this kind of a pattern. Okay, and this end of this feed, it is connected to a port, right? So this is called as a, just a minute. So this one, this green part is called as a port. So you can see that there is something called as a lumped port here, source or port. So this is where you are giving the input to your antenna. So you have an antenna, it should have an input signal, right? So in this port or source, you are giving the input, and these feed lines, these lines that are coming, these are called as the feed lines. Yeah, these are called as the feed lines. This is called as the feed lines, that from here you can see the input will travel through this feed lines to this patch, and similarly it will travel through the feed line to this patch. Okay, so this is the port, and after that I'll just fit the view. When you fit the view, you can see there is something called as a radiation box. So this is called as a radiation box. So after designing ground, substrate, patch, feed line, port, and everything, the whole antenna system, it has to be inside a box called as radiation box. So here we can see this is the, sorry, yeah, so this is the dimensions of radiation box. And radiation box is consist of air, because we are actually telling the software that uh, it can radiate, because if you are putting a radiation box and if you have any other substance like vacuum or some other thing, uh, there is a possibility that you won't get any radiation pattern. So you need some conducting material like air or something, so that you can get the radiation pattern. Okay, so that is why for radiation box we have radiation pattern. So these are the, this is how you physically design the antenna. And after the physical design, next step comes is the boundary condition. So if you check the boundary conditions for radiation box, you have to assign this boundary as radiation. Okay, you can see that. So you have one boundary which is radiation, and another one which is perfect conducting, and others. So what you're doing is you have one radiation which is for the radiation box, and you have two perfect conducting surfaces, that is one is ground and one is patch. So this is ground, you can see, just right click, assign boundary, perfect E. And patch also similarly, right click, assign boundary, perfectly. So we are saying that the ground and the patch, both of them are perfect conducting materials, because they have to be perfect conducting materials, so that you can so the radiation pattern can be there. So it has to be perfectly conducting material. And the radiation box, that is its boundaries radiation, right? So we have completed the design, we have completed the boundaries. The third thing that comes is the excitation. So excitation is given to this port, this small port. So for that, what you're doing is go to the port. So you have port somewhere, yeah, source or port, and assign excitation and lumped port. When you do that, you can see that it will be assigned automatically. The input signal will be assigned, or it will be excited. The source or port will be excited. So we have completed the first three steps. Now what you have to do is go to analysis, set up a sweep frequency. So it is 1 to 5, so it depends, you can have any sweep frequencies. So now I have given 1 to 5 frequencies. I'll tell you, you can understand when you go to the result, you will understand why I have given. So whatever resonant frequency you need to have, you have to give it before that, so that you can find the rest. So in between this 1 and 5 itself, you can find that our antenna will be resonating for 2 times. Okay, so after giving the frequency sweep, you have to validate the model. So when you validate the model, you have to make sure that you're getting all green ticks. Okay, all green ticks means that your model is ready to be simulated and it is correct. Whenever you see a red cross mark, it means that the model is not correct. It is not ready to be simulated, it is not correct. Okay, so after validation check, you have to click this. So this is called as analyze, or we're simulating it. When you click this, the simulation will take place, and this is the result you'll get. So the result, you can see that At two places, the antenna is resonating at 2.422 and 4.0667. You can see that the antenna, it is resonating. Okay, and similarly, you will get what is resonating. Why we call this resonating is that this is return loss. So whenever the antenna is resonating, at that point you can see the return loss will be the minimum. So at these 2 points, you can see that the return loss are at the minimum, right? And you can also go for 3D plot. This is the 3D plot you're getting. So you can see that the top portion, that is where the it's a very interesting figure. So the top portion, you can see this is where it's more resonation is there, and here also you can see some of it are resonating, but in the middle part it is blue where there is no resonate, there is no radiating, not resonating. Radiation is very less at this middle part and it is very high at the top part. Okay, so this is how you get the antenna 3D polar plot. So this is how you design a circular patch antenna which is resonating for two frequencies.